Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is a killer of a question. It's a time of flight, and according to the examiners, it was a demanding question. And when they said the students found it demanding, you know, students didn't have a clue. Let's see what we can do. So the question is, a sample of bromine was analysed in a time of flight mass spec and found to contain two isotopes, bromine 79 and bromine 81. And of course this is a year one question, right? You probably knew that because of time of flight. After electron impact ionization, so there's a reason why they said impact ionization, all of the ions were accelerated to the same kinetic energy. And that is key into this entire question. And then travel through a flight tube that was 0.95 meters long. Okay, so there are two isotopes. The bromine 79 ion took 6.69 times 10 to the minus 4 seconds to travel through the flight tube. Calculate the mass in kilograms of what? Of bromine 79, and then calculate the time taken for the bromine 81 to travel through the same flight tube. Wow. Now, the first thing, let's take this question into sort of steps, yeah? And of course, they've given us these Avogadro's constant, and the fact that they've given us Avogadro's constant means you probably need to use it somewhere, right? And then they've given us this these equations: kinetic energy equals half mv squared, mass in kilograms. Okay, I'm thinking, well, that's in kilograms, and suddenly they want us to find that in kilograms. Okay, fine. Velocity, speed, meters per second, and of course they've given us another equation: velocity equals distance divided by time. Remember your GCSE physics, where d equals distance in meters and t equals times in second. So what they want is mass of one ion of bromine 79 and time taken by bromine 81. And it's a 7-marker question. Obviously there's another part to it, but it's a 7-mark question. Alright, so the first thing, let's do the first part. Calculate the mass in kilograms of one ion of bromine 79. Now the first thing that students often, I mean, you know, we teachers and students deal with it, chemists deal with it day in, day out. Yeah, what is that? What is that? I'm sure every student will be, I hope every student will be able to tell you, yeah, it's the atomic mass, right? But what does it actually mean? And that many students will be able to tell you. Yeah, they'll be able to tell you that's the mass, you know, that's the protons and the neutrons added together, blah, blah, blah. But what does it actually mean? Well, this is another name for this atomic mass is called molar mass. Now, what that means is what it says on the tin, mass of a mole. So that means this is 79 grams. So 79 grams is what 1 mole weighs. So 1 mole of bromine 17 of bromine, so 1 mole of bromine weighs 79 grams, right? And this is, I'm thinking, well, what do they want to know? Calculate the mass of one ion, not 1 mole of ions. And of course, this is now you realize why they're giving you the Avogadro's number, because in 1 mole of ions, how many particles are there? How many ions there are? There are 6.022. Sometimes that's just 2 decimal places, but you know, I'm going to use what they've given me. So that means there are these many particles in 1 mole. So these many particles weigh 79 grams. And therefore, they want to know 1 ion. So therefore, 1 ion weighs 79 grams divided by however many particles there are, which is Avogadro's number. And you do that, and that is 1.31 times 10 to the minus 22 grams. That is 1 ion weighs that many in grams, because remember we use that grams, 79 grams, but they want the answer in kilograms. Okay, so I've got to change that to kilograms, and therefore that equals that divided by 1000 to change grams to kilograms. So it'll be 1.31 times 10 to the minus 25 kilograms. And so that is your first answer. Yeah. Calculate the mass in kilograms. Yeah, apparently a lot of students did get that right. Okay, some students obviously just did 79 divided by that number, Avogadro's number, and left it there. But what they didn't realize is that mass is in grams. That mass is in grams, not kilograms. So anyway, you now got mass of bromine 79 in kilograms. And I guarantee you, you might have to use that somewhere later. Let's see. So that's one question done. Second, calculate the time taken for the bromine 81, so this is a different ion, to travel through the same flight tube. Okay, and they've given us all of these. Now, what am I thinking when I look at this question? I'm thinking they've given me a distance. So this is the length of the flight tube, the distance that the ions travel. So where is that on the distance? Okay, well that's this here. Okay, and they've also given me, okay, the same kinetic energy. So they said both of them are same kinetic energy. Okay, I'll need to remember that. And then they're saying I've now got the mass of Br71, right? Now, so I've got mass is, so my thinking is one of the variables they've given me is in this equation, and one of the variables they've given me is in this equation. So I probably have to combine these equations up. Yeah, because obviously otherwise I'm going to have too many unknowns. I don't know what the kinetic energy is. I don't know what the velocity is. Yeah, so I got too many unknowns. So I can actually combine these two equations. So I'm going to try and make these into one. So here it is. I'm going to make it into one, right? So kinetic energy equals mv squared, right? But I know that v is d over t, distance divided by time. So I'm going to swap that, substitute that v for distance over time. So this is now going to be equals half m distance divided by time squared. The reason why students gave up on this question too easily is that, oh my god, this whole bracket, a fraction being squared, oh my god, I don't know what I'm doing, I'm moving on to the next question. No, stop. Calm down. Half the problem with these kind of questions, you know, where they've given you so much data, is panic. Yeah, you cannot allow yourself to be panicked. Yeah, that's the first battle you got to win. When you see a question like that, right, you got to just take a step back, take a deep breath, and say, let's just walk through it. Yeah, let's just do this question, do whatever we can. Yeah, just read the information and try and see what we can get. Yeah, so half the battle is panic. If you don't get panicked, yeah, by looking at that question, that's half the battle won. All right. So anyway, so the next battle is here, isn't it? Oh my god, fraction squared. Oh my god, you know what I'm going to do, right? Not a problem. Let's continue. Okay. Now, here's the key. All right. And if it was me, I'll tell you two ways of doing this, because there are two ways, but this is how I would do it. They've told you that it's the same kinetic energy. So you know that Br79 and Br81 has the same kinetic energy. So therefore, the kinetic energy of, so remember I'm using that equation now, 79 will be half m d over time squared, and the kinetic energy of 81 will be the same, half m d squared. Same kinetic energy, isn't it? And if this is the same kinetic energy, then that means I can make that equal to that. So watch this now, half m d over t squared, I think you can still see it, which equals to that energy, half m d over t squared. Now, before I go any further, two things I need to realize. One, that this belongs to the 79 bromine ion isotope, and this belongs to the 81. So this mass belongs to 79, this mass belongs to 81. So I've got to differentiate it somehow. So I've got to label it somehow. So what I'm going to do is I'm going to say this is M79, and of course the time taken is for the 79. This time taken is for the 81. And of course this mass is 81. The distance, well, it's the same distance for both of them. So I don't need to differentiate it. I don't need to label it. It's the same. Okay, now, so that's the first thing. Yeah, differentiate where they differ. And the next thing is, well, half there, half there. If it's on both sides of the equation, I can cancel it out. Can I not? They're on both sides. And also, look at that distance. If this distance is the same as that distance, it's the same thing on both sides. So I can cancel it out. So I'm going to rewrite it just to make it slightly simpler, right? So this will be now M79. I'm going to move this paper up in a minute. 79, and remember that is T79 squared equals M81, and that is 1 over T81 squared. Remember, it's still 1 over T because you cancelled that at the top. Yeah, that's still below the division line, isn't it? Right? So now I can change this, yeah, to make it slightly simpler, or simplify it. So watch this. Now, you can do it. I hope I don't need to explain it, right? So this is squared and this is squared. This is squared and this is squared, okay? But what that means is 1 squared is 1, isn't it? 1 squared is 1. So I can actually change it to this. M79 times by 1 over T79 squared. And then this is M81 times by, 1 over T81 squared. Alright, I can rewrite that to make it even simpler. Right, and remember, in the exam you won't be doing these many steps. Why? Because you can go straight from that step to that step. The only reason I'm doing it is just to show you. Equals, now remember the question, calculate the time taken for the BR81. So in other words, it's that I need to make the subject of this formula. So all I'm going to do is I'm going to bring that up, and I hope you're good at maths, rearranging equations. Yeah, so you know this is being divided, so you multiply everything by T81, and that'll get rid of that over here, and then of course it will bring it up here. So I hope you can do it that long way, but I'm going to now take a shortcut. Yeah, so I'm going to bring that up here, and I'm going to swap these around here. So I'm going to move these around there, bring that up here. And how am I going to do that? I'm going to move this up a little bit. So this becomes T81 squared equals M81, and I'm going to bring the whole lot on this side, but it's going to be reversed. Yeah, if you don't know how to do this, let me know and I can go sort of step by step in one of the other videos. Okay, so M81 multiplied by T79 squared over M79, and of course that'll give me T81 squared, time squared. I don't want time squared, I want time. Alright, so I'm going to have to square root it. So this will be, so this is T81 equals, I'm going to square root that and square root that. M81 T79 squared over M79, and then I'll have to square root of it. And now think about it, all I need to do is, I've got the mass of 81, so that's obviously 81, you know, bromine 81, isotope, the relative atomic mass is 81, the relative atomic mass of that is 79, so I can actually just put that in. So slot the values in, and I will just change over. So all I'm going to do is slot the values in, so it's M81, which is mass of 81, or 81 obviously, yeah, times by, now what is this T79 squared times 79? So time for the 79, yeah, and that they tell you already there. Time for 79, 6.69 times 10 to the minus 4, so it would be 6.69 times 10 to the minus 4 seconds, and that of course, not forgetting, needs to be squared, and then divide that by M79, which is mass of 79, which is 79 obviously. Yeah, and then of course I need to square root all of that. Now having done that, what the students often do, and I'm finding this out, is when they use a calculator, they start slotting in everything, all of these, yeah, all together, 81 times 6.69 times 10.94, 10 to the minus 4, yeah, and squared. They don't use brackets. Please use brackets. And then of course they do divided by 79 all in this one go without using brackets, and you get some odd answers, yeah. So use brackets, please. Okay. So the answer to that would be 6.77 times 10 to the minus 4 seconds, and that is the time taken for the BR81 to cross that tube. Yeah, end of the question for that part anyway. Yeah, it is a long question, there's no doubt about it, but some of it is long because I showed it to you. So from here, once you've understood that, you can cross out all of these because you can do them in your head. Yeah, but even if you can't, right, I've just shown you the way how to do it. Anyway, this is one way, and I'll tell you where the marks are, but this is one way of doing it. So the marks would be here, here, and then putting in values here and here. Okay, so 1, 2, 3, 4. Oh, one mark is for this as well, yeah? So it's 1, 2, 3, 4, 5. Okay, but look, just because, yeah, you know, you have to think, there's no doubt, you had to think about this question, right? But the key point in this question was the fact that the kinetic energy of both ions is the same. So you could have just equated the two kinetic energy equations, yeah, for both ions. And then once you do that, you'll find that this cancels out, that cancels out, this cancels out, and it becomes a lot simpler. Yeah, I know, you know, this 81, you know, labeling of these, you know, 81, 79, yeah, that makes it slightly complicated, yeah, but it's not that complicated. Yeah, you could have labeled it A, B as long as you knew what A and B was. Yeah, I just found that 81 and 79 actually made it really understandable because 81 I knew was for bromine, you know, 81, and 79 was for bromine 79. Yeah, but you could have labeled it anyhow you want as long as you remembered. Yeah. But yeah, so it is one of those questions that they found difficult, the students, and a lot of the students, they probably got to that stage, but a lot of the students could not do the rest of it, so they actually lost marks. Okay. Okay, is there another way of doing it? Well, yes, there is. Okay, I'm not gonna go on to the second part just yet, but let me show you the second way of doing this. And the second way, it depends on how you find it easy. I would have approached it the way I've showed you, but a second way would be very simple. When I say simple, it's up to you what kind of person you are. So the second way would be you find the velocity of the 79 isotope, because they've given you the distance 0.95 and they've given you the time, yes, how long it takes. So you work out the 0.950 meters divided by the time, and I'm not going to do this, I'm just going to show you generally. I mean, you can try it yourself later if you like. Yeah, so you find the velocity of the sort of 79 isotope, then you use that velocity and find the kinetic energy of the 79 isotope, half mv squared. Yeah, you just found v, so you just put it into that equation. So once you find kinetic energy, what you then do is you use that kinetic energy to find the velocity of the 89. So for example, you say, okay, well look, kinetic energy 81, yeah, and that of course kinetic energy is the same for 79 as it is for 81. We know that kinetic energy in time of flight is always the same, yeah. So for all ions, yeah. So I would rearrange that. So this is my equation. So this is now m81 v squared. So I would rearrange that to give me velocity of the 81. Velocity of 81, and I'll just literally rearrange that to say ke. So that's 2ke because I'm moving that across, divided by m. And then, because this is v squared, I'm going to have to square root of that. So then you find v81, right? And once you found the velocity of the 81 isotope, then you use that same equation again. Yeah, you know the distance is still 0.950 meters, right? And so you just found out the velocity, so you put the velocity in here, okay, and rearrange it for time, and you find the time. Okay, so you could have done it. So find the velocity of 79 isotope, yeah, use that to find kinetic energy of the 79 isotope, and then use the kinetic energy, the fact that all kinetic energies are the same, then you use that kinetic energy, assume that's the same as for 81 isotope, find the velocity, okay, for 81, and then use that to find the time. Okay, so you could have done that and you'd get to the same answer. All right, and again it would be 1 mark each if you did do it this way. All right, so that's that. And of course the second part of this question, worth only 2 measly marks, is explain how ions are detected and relative abundance is measured in a time of flight mass spec. Again, that's 2 actually questions in one. Ions are detected, and of course 1 mark for each, I'm assuming. How ions are detected and relative abundance is measured. Right, so how ions are detected. Now, what you need to understand is if this is time of flight, okay, and there's your detector, right, when ions hit the detector, they're usually positively charged, yeah, these ions. And when they hit the detector, they actually gain an electron. Right, so an electron goes from the detector to the ion. That movement of electron is current. So, explain how ions are detected. Well, when ions hit the detector, they gain electrons. 1 mark. Okay, and a lot of students didn't know that. Yeah, they missed that point. The fact that it's the transfer of electrons from the detector to the ions, that is current. Okay, and then a lot of the students did get the 2nd mark where they said the abundance of the isotope, or the abundance, is proportional to the current. So the greater the electrons, number of electrons moving, the greater the ions. Yeah, so the 2 marks was for electrons transferred to the ion. So ions hit the detector and gain an electron. The current is proportional to the abundance. Don't worry about that. That's just a proportional sign. Yeah, in maths. Yeah, you can actually write down. Yeah, so that's actually 2 marks. So 1 for saying that they hit the detector and they actually gain electrons. A lot, as I said before, lots of students didn't realize that, and even if they did, they didn't mention it. And of course, the amount of current is equal to or proportional to the amount, the abundance of the ion. Okay, so that's another 2 marks. So that's 4, 5, 6, 7 marks in total. This is one of those. You know what? Time of flight is a new thing, right? In the sort of syllabus, yeah. So I wouldn't be surprised if you continue to get more questions on, like that. And they know, the examiners know, that these kind of questions put students off. All right. So I wouldn't be surprised if they put more questions like this in, yeah, because this kind of a question is a real differentiator between someone who understands their topic well and someone who's just scraping by. Yeah, so this actually differentiates between a higher ability students and lower ability students. So my suggestion is do more of these kind of questions. Yeah, so practice these questions. Yeah, so if this does come up, you'll get 7 marks, easy. All right, but think your way through this question. Okay, don't let it worry you. Don't let it panic you when you first see it. Okay, well look, let me know how it went. So this was one of the questions. It wasn't a requested question. It's just I came across it. And I've been thinking about doing this for a while, actually. Yeah, because obviously our students found it difficult, and I had to explain it to them step by step. And it was in the back of my mind that I am going to do one of these time of flight questions. So here you go. Let me know what you think. Okay, and please subscribe and also like and share the video. Okay, any other ideas, any other particular questions? There are obviously students asking me for these questions. They are sort of suggesting some questions. I'm getting through them slowly. Okay, but if you do have any suggestions, or if you've got any improvements on this, if you know a better way of doing this, an easier way of doing this, I'm all ears. I'm always willing to learn. Okay, right, I'll see you next Wednesday. Bye.